Look at that mini table. Mini table is not a beloved thing for me, but you guys might really like it. I prefer myself the unit circle because it also tells you where an angle might be, like which quadrant it might be in. But anyways, let's more doing. Okay, let's look at the first quadrant. Here's our first quadrant with our common angles right here. That one is usually your 30, your 45, and that one's your 60. We're going to use radians since that's what we're talking about over here. So we have pi over 6, then pi over 4, and then pi over 3. So we're going to write those dudes right here. But first, let's count it out. You guys remember when we counted around the unit circle, we counted by 15 degrees, right? Here we go, 15, and then 30, 45, 60, and then 75, and then 90. Well, in radians, you wouldn't count by 15, obviously. You would count by pi over 12. So let's do that. Let's go pi over 12 right here. And then that would be 2 pi over 12. That would be 3 pi over 12. Then we have 4 pi over 12, 5 pi over 12, and 6 pi over 12. The only disadvantage or downside of doing it like this is now you have to simplify almost all of those fractions. And if you can't simplify them, then you don't want them. So like this, for example, this first one right here, we don't want that, dude. Let's just cancel them out. This one simplifies to, let's see, divide the top and bottom by 2. It'd be pi over 6. And then the next one, when we simplify this one, that would be pi over 4. And then this one, when we simplify it, is pi over 3. We don't care about that, foo. And then this one right here, when we simplify this one, this quadrantal angle, it would be pi over dos, because you divide the top and bottom by 6. Let's not forget our friend 0 radians. Also, in the first quadrant, we have to know the coordinates. The coordinates of every single one of these points. So like the coordinates of this point right here. All right, what are the coordinates of that guy? Oh, let's not forget this dude down here. We have the coordinates of this one, coordinates of this one, coordinates of this one, and last but not least, the coordinates of the dude up top. The two easiest sets of coordinates are going to be at the very beginning and at the very end in this first quadrant. That would be 1, 0, and then 0, 1. Okay, remember this is a unit circle, so the distance from here to here would be 1. That is the radius. The next easiest one to remember, not just me, I guess, when I say that, is the middle one. That is rad 2 over 2 and rad 2 over 2. I guess it's because pi over 4 is in the middle right here. And since it's in the middle, the co-height and the height should be the same. And then we have the last two guys. All right, this one right here is rad 3 over 2 and 1/2. And then that switches spots 1/2 and rad 3 over 2. Okay. Why? How do we get all those? Do you guys remember height and co-height? Which number represents my height right here? The 1/2. And then this would be the co-height. Which is longer, the co-height or the height? The co-height is longer. And that's how I remember that the x is always rad 3 over 2 at pi over 6. At pi over 6, the x is bigger than the y. That's how I remember that rad 3 over 2 is the x value. That's your co-height. And then over here, when we go to this point right here, the sides, the height and the co-height, switch values. All right, enough of that. Let's fill in our trigonometric values. So sine of pi over 6 is 1/2. That's because when I look at pi over 6 and I look at the height number, which is y, we get 1/2. At pi over 6 for cosine, we're looking at the co-height, which is the rad 3 over 2. The co-height is x. And so we write rad 3 over 2. Now let's hop over to pi over 4. Pi over 4 is rad 2 over 2 and rad 2 over 2. That one's, again, like pretty easy to remember because they're the same. And then for the pi over 3, we're switching these spots. Remember, that's what I was talking about right here. We switched those spots. So I put the rad 3 over 2 right there and then the 1/2. And then some of you guys might want to write this down. This is the x value and this is the y value for all coordinates. Your cosines are x, your sines are y. How did you guys remember in algebra, pre-algebra, that your x was first and your y was second? Does anybody? I always thought of the alphabet. X is first, so it goes x in the alphabet is first before y. That's how I remembered when I first learned how to do that. Well, you can do that with the trig functions too. Check it out. C is before S in the alphabet. The cosine is always first, and then the sine. All right. What about our friend tangent over there? Tangent. How do we find that foo? Well, tangent is also known as slope. So if we were trying to find a tangent of pi over 6, we just need to find the slope of this line right here. Okay, what is the rise and what is the run? What is my rise and what is my run? Well, in this case, since we're starting at the origin, the rise is 1/2 and the run is rad 3 over 2. And so slope is rise divided by run, correct? So we're going to go rise divided by run. How do you do that? Oh, you guys remember when you multiply fractions? What do? You multiply by the reciprocal. So I'm going to go 1/2 times 2 over rad 3. Oh, snappity backity shackity. Okay, so when you guys are multiplying these, hopefully you guys see that you can cross cancel with these 2's. Peace out, peace out. They both equal 1. And then what do you get when you multiply straight across? 1 over rad 3. But we cannot leave the radical on the denominator because this is algebra 2. If you were in calculus, you could leave it like this, but you're not. So rationalize that down. You guys can't leave this square root on the bottom. So we're going to have to multiply the top and the bottom by rad 3. What is 1 times rad 3? Rad 3. And what is rad 3 times rad 3? 3. So we get rad 3 over 3 is what tangent is at pi over 6. This one's simple. What is that divided by that? Sine divided by cosine. Oh, so the x or y divided by x is the same as saying like sine divided by cosine. Okay, yeah, that's 1. Very good. And then what do you suppose we're going to get right here when we switch it? I don't know. Let's write it out. We have rad 3 over 2 divided by 1/2. And then we have to change that to multiplication. So we're going to go rad 3 over 2 multiplied by 2 over 1. And then we have some more cross-canceling action here. I love cross-canceling. Yay. All right, so I get rad 3 over 1, which is just rad 3. Okay. Is everybody good with how I got rad 3 over 3? Or shall I be more detailed? Be more detailed. Okay, check it out. I have to multiply the top and the bottom by rad 3. And whenever I do that, like rad 3 divided by rad 3 is 1. And if I multiply 1 over rad 3 by 1, I'm not changing it. But I am going to change the way it looks. All right, so I get rad 3 up top, and then I get the 3 on the bottom. Because rad 3 times rad 3 is rad 9, and simplified is 3. That's how we got that. So that's a mini trig table, people. Some people memorize this. It's up to you. You can memorize that. I didn't. This is what I remembered. I remembered my unit circle.